C over O. Hence, the answer would be no limit or infinity. So, kaning undefined kay if imo siyang i-direct substitution, ang x equals to a, i-direct substitution nimo siya, undefined siya kay ang muguwas is C over O. So, constant over 0. Limits can be obtained by directly substituting the value of a or changing the form to its simplest form by either rationalizing or factoring. So, kaning limits using direct substitution, kay na siya'y two ways. It's either diretso nimo substitute wherein makakuha ka directly sa limit or imo pa siyang i-change ang form sa function nga given into its simplest form. Either imo siyang i-factor para na kay ma-cancel out or imo siyang i-rationalize. So, kay bao naman tingali mo tanan sa unsaon pag-rationalize sa function or sa given. So, there are laws of limits. So first is limit of C where x approaches A is equals to C. So kani siya inyong timan-ara jud sa limit sa kay unsay porma sa kanang given nga gihatag. Inyo siyang tan-awon kung asa siya nabilong na law sa limits para maka-apply mo sa sakto nga answer or pamaagi unsaon pag-answer. So I think your teacher gives you these 7 laws of limits. So diretso na lang ta sa examples. So example 1, limit 12 where x approaches to 3. So naman diri sa laws of limits sa number 1. Nga limit of c where is c kay constant. So number 1, limit of 12. So bisag unsa pa ang x, value sa x, if approach man siya negative number, approach man na siya 1 million, ang answer ra jud ana kay constant. So 12. Na may questions, by the way, before ko ma-proceed, na may questions? Okay, continue. Okay, wala may nitingog. So, example number 2, given the function 3x squared minus 3x plus 2, where x approaches positive 3. So, imo siyang tan-awon if pwede ba nimo siya ma-simplify or dili. So, pag tanaw nimo sa given, dili man siya ma-simplify na. So, mugamit kag direct substitution. Idiretso ra nimo substitute ang value sa x. So, x equals a. So, ang value sa x dire kay x approaches to 3. So, 3. Ang kaning mga x nga naa sa given equation or sa function, imo siyang ilistag 3. So, limits is equals to 20 if imo na siyang imo na i-solve. So, number 3, limits of x minus 3 divided by x minus 2. Oh, ito na-typo ko. Sorry. Wait lang. So, continue. So, limit of x minus 3 over x minus 2. So, igkatanaw nimo, wala man gihapon kay, di man gihapon nimo siya ma-simplify. So, imo ra gihapong direct substitution. Ang x approaches negative 2. Wherein, makakuha ka og 5 over 4. So, ma-positive na siya kay ang makuha nimo sa babaw, negative 2 minus 3, negative 5. Ang sa ubos, negative 2 minus 2, negative 4. So, negative 5 over negative 4, positive 5/4. So, example number 4. Dami kong ano. Sorry guys, daghan kayong typo. Typo. So, kani kay 2/0 man siya. So, dili, if 2/0 siya, makaingon ka nga, no limits kay undefined man na siya. If ingon ani na situation, it's either i-simplest form nimo, if dili ma-simplest form, it means no limit jud siya, wala jud siya limit ang kaninga given. Number 5. If f of x is equals to x squared minus 2, solve limit of f of x minus f of 2 all over x minus 3. So, kani, gitagaan ka, murag naman ni siya sa math, sad nga kanang gaan mo function. Say, tawag ka na, nakalimot ko sa term. So, gitagaan ka nga f of x equals x squared minus 2. So, una, imo sang isolve ang simplify sa nimo ang f of x and f of 2 before ka mag-substitute sa x equals to 5. So, next is limit of, di ba, ang f of x kay x squared minus 2. So, imo na ibutang diri x squared minus 2 minus f of 2. F of 2 kay 4. 4 minus 2. Kaya imo pa maning isolve da ng f of 2, which is, ang kaning value sa 2 diri sa f of 2, imo na siyang i-replace diri sa x, diri sa kaning given nga function. Kani, para ma-solve nimo ang f of 2. So, mo na, x squared minus 2 minus quantity 4 minus 2. So, simplify ni nimo kani, makakuha ka ning limits of x squared minus 4 over x minus 3 where x approaches positive 5. So, substitute na nimo at x equals to 5, limits is equals to 21 over 2. So, ayun na ra ang direct substitution. Imo ra siya i-direct substitute if ang mogawas gani constant over 0, undefined, imo siyang tan-awon if ma-simplest form ba nimo siya or dili. If dili na jud gani siya ma-simplest form, mao ra jud ang answer, constant over 0, kuha na siya. Ang answer na niya kay no limit. So, kisa may na question ani nga topic, you can raise questions. So, I hear none. I will proceed to the next topic. So, limit of indeterminate forms. Consider a rational function. Excuse me for a while. Okay, consider a rational function in the form of f of x is equals to n of x over d of x. When x is equals to a results to 0 over 0. So, kaning sa indeterminate forms, if imong i-direct sub na po, if imong gamitan og direct sub, if ang result gani 0 over 0 or infinity over infinity, mag-assume ka nga indeterminate form na siya. So, mao ra na ang sa indeterminate form ra, makaingon kag indeterminate form, if gamitan nimo og direct substitution ang given, ang result niya kay 0/0 or infinity over infinity, dili ka mo ingon nga, ay 0 na ni answer ani niya diretso, dili ka mo ingon ana. Nga 0 na ang answer. Mo-assume ka nga indeterminate form to ang gihatag. So, if indeterminate form gani, naanay two possible ways to solve the limits sa katong nga given. It's either factoring or rationalizing. Same rasad sa katong first topic ganiha nga, if constant over 0 ang mo result, imo siyang i-simplest form or i-change ang form para makakuha ka sa possible limit. So for example, number 1, limit of x cubed plus 64 over x plus 4, where x approaches to -4. So if imo ning i-direct substitution ang -4 adto sa x diri sa given, ang resulta na niya kay 0/0. So, kay 0/0 man ang result, mag-assume ka nga indeterminate form na siya using direct substitution ang kani nga given. So, para makakuha mo sa answer, ikatanaw ninyo, pwede man nimo ma-factor ang naa sa numerator para ma-cancel nimo ang denominator and maka-come up ka into new form. So, imo siyang i-change by factoring. Ang form, i-change nimo ang form by factoring. So, limit, ang factor sa x cubed plus 64 is x plus 4 times the quantity of x squared minus 4x plus 16. Mao nay factor sa x cubed plus 64. So, karon imong tan-awon na ay ma-cancel out, which is ang x plus 4 sa numerator and an x plus 4 sa denominator. So, maka-come up na kag new form. Limit of x squared minus 4x plus 16 where x approaches to -4. So, in this time, na naka new form, pwede na nimo siya, kaninga new form, pwede na nimo i-direct substitution ang -4. So, substitute x equals to -4 to the new form, then makakuha ka og limit nga 48. So, diri na pod na example. So, kani limit of 4 minus square root of x plus 16 over x, where x approaches to 0. If imo ning i-direct substitution, ang 0 diri sa given, mag-assume ka nga ang makuha jud nimo kay 0/0. So, ikatan-aw nimo sa given, dili ka maka-factor. Kay di wala man kay ma-factor. So, imong other way is to rationalize the given. So, kabaw na mo rationalize, conjugate method gamiton. So, mo ani ang pamaagi. Muna siyang i-conjugate ang numerator. So, multiplyan nimo og 4 plus square root of x plus 16 over 4 plus square root of x plus 16. So, next, ang makuha nimong answer is limit of 4 squared minus square root of x plus 16 quantity squared over x times the quantity of 4 plus square root of x plus 16. So, imo na siyang i-solve, i-simplify, multiply. So, makakuha kag limit of 16 minus x minus 16 over x times the quantity of 4 plus square root of x plus 16. So, continue. Imo na siyang i-solve. 16 minus 16. Ano Wa na ni. Ma-cancel out ang 16. So, nanalay kay negative x. Na ang mabilin mo diri nga part kani negative x. Naman kay x sa ubos, so pwede nimo ma-cancel out. And ang mabili nimo sa babaw is negative 1. So, this time, dili naman nimo mausab ang form. Mao naman ni ang simplest form sa imong pag-rationalize. So, pwede na ka substitute sa x wherein equals to 0. So, if imo i-substitute, ang makuha nimo nga limit is -1/8. So, if kisay na i-question about sa topic nga indeterminate form, you can now raise your hands and ask a question. So, I hear none. So, let's continue to the last topic. So, the last topic is limit at infinity. Ako maingon ra jud sa limit at infinity sa kay naa ra jud kay 3 ka reminders nga dapat jud na nimong hinumduman when x approaches to infinity. Infinity na gani ang tabian. Tulo ra jud dapat imong hinumduman. Murag mao ni pinaka murag sayon huna-hunaon, like sayon ansiran if x approaches to infinity. You can ask your kuya sa diri nga tutors if same ra ba mig hunahuna if limit at infinity na ang tabian. So tips ra ana, imo ra ni siyang i-summarize. Ang kaning n mao ni siya highest degree sa numerator. Ang m kay lowest degree sa denominator. So mao ra na tulo ra jud imong hinumduman sa limit at infinity. First, when n is greater than m, so kung ang highest degree daw sa numerator mas dako pa sa highest degree sa denominator, ang answer na niya, ang limit na niya kay limit at infinity. So, for example, dere, example number 2. Limits of 3x cubed all over x minus 3 where x approaches to infinity. So, ang highest degree sa numerator is kaning 3. Wherein, sa denominator, ang highest degree niya kay 1. So, naaman diri sa tip nga when n is greater than m, imong answer kay infinity. So, mo na answer sa number 2 is infinity. So, tip number 2. When m is less than m, ang answer sa limit is 0. So, kung ang highest degree daw sa numerator is less than the highest degree of the denominator, ang limits nimo kay 0. So, for example, kani, limits of x minus 2 all over x squared plus 4, where x approaches infinity, answer niya kay 0. Di na jud ka magunahon ang hala, unsaon ni nako pag-solve, ma-simplify ni ingon ana. Imong tan-awon ra jud kay ang degree sa numerator and degree sa denominator. If ang tabian kay limits at infinity. So, in this example, ang highest degree sa numerator kay 1, wherein ang highest degree sa denominator kay 2. So, n is less than m man diri sa example number 1. So, if n is less than m, ang imong answer kay 0. So, tip number 3. When n is equals to m, imong limits kay a over b. Unsa may pasabot ani? So, if ang highest degree daw sa numerator kay equal sa highest degree sa denominator, ang imong limits kay a over b. A over b, a kay constant sa letter sa numerator, constant sa highest degree sa numerator, where ang b kay constant sa highest degree ay sa highest degree sa denominator. So example 3, limits of 2x squared plus 3x over 5x squared minus 3 where x approaches infinity. So imong tan-awon, ang highest degree sa numerator kay 2. Ang highest degree sa denominator kay 2. So equals man ang n ug ang m. So imong buhaton a over b. So unsa may a? So unsa may value sa constant sa highest degree sa numerator, di ba? Ang highest degree diri kay 2x squared. So unsa may constant na niya? 2. So a nimo is equals to 2. Ari pod ka sa b. Ang highest degree kay 2 gihapon. So unsa may constant ani diring 5x squared, di ba 5? So 5 nimo mo nay b. So a over b. So ang answer nimo sa kaning limits of 2x squared plus 3x over 5x squared minus 3 where x approaches to infinity, is equals to 2/5. For example, 10 ni diri nya 5 nang ubos. So 10/5, imo na siyang i-simplify, answer nimo 2. Yun ana ra na ang limits at infinity. So para na ko mo ni ang pinakamurag dali ra maansweran na topic sa limits and infinity kay kanira jong tulo, kanirang tulo ang imong hinumduman when you encounter limits at infinity. So that's all. Thank you. If you have questions, you can now raise your questions.
So I think wala na may question siguro, no? Proceed na sa next topic. Share na ako sa screen. Kita na. Hello, hello. Okay, sige. So, next topic ay differentiation rules, which is, I think, pinaka-importante sa kaning calculus, no? Kaya mo man murag magamit until sa last topic. So, recall, derivative is the slope of the tangent line to the graph of the function at that point. So, ang derivative di ay is simply the slope. We know sa high school math kaya ang slope kay rise over run. Simple ra kaya ito ipangita sa high school kay katong mga lines ra. But in calculus kay mga curves na. So, recall nga slope equation kay m, which is denoted by m ang slope, equals rise over run is equals to delta y over delta x is equals to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So, mao na siya murag basic sa basic description sa ato ang slope y sub 2. Focus lang taning naka-red kay mao tong gamiton sa next slide. So, diri recall again, m equals to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So, ayo lang kayo mo focus sa aning nga drawing kay makalibog niya. So, ang kanilang derivative kay slope raman ni siya, ma-compare na to siya sa original function sa slope na kani. So, ang kaning red nga color y sub 2 kay kaning f of x plus y delta x, ang kaning y sub 1 kay f of x, ang kaning x sub 2 na to kay mo tong x plus delta x and x sub 1 kay x. Sa kaning nga drawing, ang gibuhat na to kay di man ta ka directly kuha sa slope sa curve kay changing man na siya infinitely kina ma-change pa siya bisag asa siya nimo makuan mulihok ra kagamay nga point kay lahi na iyang slope compared sa katong initially mo nga point. So ang buhaton na to kay mokuha tag tangent line sa kana nga point din ang slope anang tangent line kay the same sa slope sa kana ra nga point. Okay, so kani second line man ni siya ato ni siyang i-tangent. How? Ang delta x na to kay atong i-approach as 0. So if i-approach din mo 0 ang kaning delta x, ang kaning line nga blue mahimo ni siya tangent sa point sa curves nga red at some point. So ang kaning initial point sa p kay x, then ang kaning ang point sa q kay x plus delta x. So ang kaning y point sa q kay f of x plus delta x kay imo naman siyang i-add. Ang kaning y point sa p kay mo ang original f of x. So we know that ang slope kay y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Ang y sub 2 na to kay f of x plus delta x. F of x plus delta x minus f of x, f of x. So divided by x sub 2 which is x plus delta x minus the x. So simplify this form kay makancel na ang x dire, so ang mabilin sa denominator kay delta x as x or delta x approaches 0. So ningon tag approaches 0 kay we want to make this second line tangent to the curve para makuha nato ang slope sa kanang curve nato at a specific point. So recall ra na siya next kay ari na sa kanang rules jud sa differentiation, which is first kay constant rule simple. The derivative of any constant is equals to 0. Ang tricky ra jud kaayo niya no kay kaning pi ug e kay most probably sa mga lisod na kay mogawas man siya and other students kay i-treat ni siya as variable. So maglibog sila unsay derivative ani. Sample like derivative of pi ilang himo og 1 kay abi nila pareha ni siya value sa x. So kaning pi ug e constant na siya. There are many other constants labi na sa physics magamit man siya na mga laing constant nga ang symbol kay letter. So be careful lang ta na more man trick kaayo sa constant nga rule. So any kanang derivative sa constant kay 0. So derivative of pi is 0 kay naman na siya value 3.14 and sa e kay 2.71 Euler's number, derivative of e kay 0. So mo na siya yung tricky kayo sa constant rule ang kaning mga number, specific number nga na ay certain symbol nga letter or Greek symbol. So next is the power rule. Mao ni ang kanang murag generalizing kayo sa tanan nga rule ba kay murag magamit nimo bisag asa. Kay sa math kay daghan man kayo ways to solve no dili man kay usa. So ang kaning power rule kay murag ma-apply na nimo bisag asa if kamao jud kay ka sa kwan. So the derivative of x raised to the power of n is equals to n x raised to the power of n minus 1 where n can be any number. So for example na dito kay para mas masabtan ang x kay variable, ang n kay any number or your constant value like 1, 2, 3, 4, 5 so on. So derivative of x cubed is equals to i-bring down nimo ang iyang exponent which is 3, i-multiply nimo siya sa original function but ang imong exponent imong subtract ka ng 1. So in this case x to the power of 3, bring down ang 3x cubed, 3x raised to the power of 3 minus 1 which simplifies 3x squared. So next kay kana fraction ang ihang power. So ang kaning ingani nga case kay nani siya lain nga kaning giblo ganin ako nani siya lain nga rule but as I said earlier nga magamit din nato ang power rule almost sa any problem. So derivative of x raised to the power of 1/2 is equals to the derivative of x raised to the power of 1/2 is equals to the derivative of square root of x kaya kaning x raised to the power of 1/2 equals naman sa square root of x. But anyway, gamitan na to ang kuan, ang power rule which makes ato i-bring down ng 1/2, ato i-multiply sa x, but ang power sa x kay minusan na to 1. So 1/2 minus 1 is just equals to minus 1. So mo na dire 1/2 times x raised to the power of minus 1/2. Then sa rules of exponent kay if ang imong exponent kay negative, to make this positive, imo siyang i-change position from numerator to denominator to numerator. Since in this case, naam siya sa numerator, to make this kanang exponent positive, ato siya i-bring down sa denominator. So that's why atong answer ay 1 over 2 x raised to the power of 1/2. And we know x to the power of 1/2 is equals to square root of x. So man ang y over 2 root of x. So next kay ang kani kay d of derivative of x plus quantity x plus 2 raised to the power of 6. Same ra ni siya og ganang way but ang atuang gi-raise na lang ani kay composite function or function inside a function. So ma-discuss na siya later sa lain nga rules. So ang kaning raise negative number still applicable imo ra gyud bring down ang exponent, minusan ni magwa ng exponent and rules sa mag-subtract ka og kwan different forms kay change the sign of the subtrahend and proceed as in addition. So ang rules ang sign sa atong 1 diri kay positive niya ang ato ang operation kay minus. So natay negative 11 minus positive 1, change the sign of the subtrahend which is minus 1 ay plus 1 atong ihimog minus 1 and proceed as in addition. So minus 11 plus minus 1 is equals to minus 11. So negative 11x raised to the power of minus 12. Mao sad nang pinaka-importante sa kanang calculus no, basta ma-master nimo ang algebra kay murag ma-master sa dinimo ang calculus kay kani kay more on loss ra man jud niya murag imo ra siyang masag-o ang lisod mong nga part sa calculus kay dili man ang calculus itself ang kana mang pag-simplify, pag-solve, pagkanang rationalize, pag-apply sa mga exponent rule may ana ba no. So it's better nga ma-master nimo ang algebra before ka mo dig deeper kayo sa calculus. So, next kay addition rule, the derivative of the sum of a function f and a function g is the same as the sum of the derivative of x and the derivative of g. So in this case, ang derivative basta na kay duha ka function nga imong gi-add, then you want to do differentiate sa kana nga function. Imo na siyang ibuwag ang duha ka function and then i-derivative nimo siya tagsa-tagsa. Mao ni ang mathematical description niya. Gibuwag ra nimo ang derivative, ra nimo gi-distributive property ba. So let's take for example x squared plus 2. We know na makasolve man taning x squared plus 2 kay tungod atong power rule. So ato the derivative of x squared, quantity x squared plus 2 is equals to the derivative of x squared plus the derivative of 2. And we know the derivative of x squared is 2x raised to the power of 2 minus 1. Then the derivative of 2, which is constant, is equals to 0. Na kaning x squared kay gimitan na to power rule, which is ang numerator, ang exponent i-bring down na to, then minusan na to 1. So that's why ma-simplify siya as 2x. So derivative of x squared plus 2 is equals to 2x. Simple lang addition rule. Same sa difference rule. Simple, ang nakalahi lang nila kay ang operation. So same concept kanang imo ra siyang buwagon, but ang difference kay ang iyahang minus sign. So the derivative of x cube, example, derivative of x cube minus x minus 3. So ibuwag nimo ang x cube, ibuwag nimo ang x, ibuwag nimo ang 3. Then don't forget the sign. So derivative of x cube, power rule, i-bring down nimo ang 3, then minusan nimo 1. Then derivative of x, naman na siya imaginary nga, or not imaginary, but na siya exponent jud nga 1, basta dili maka-indicate, automatic man na 1. So i-bring down na to ang 1. Then ang 1 minusan na to og 1. Then ang derivative sa constant kay 3, constant nga 3 kay 0. So i-simplify 3x squared minus 1x raised to the power of 0. Then cancel out na ni 0, wala na ni siya. So any number or any variable raised to the power of 0 is just equals to 1. Bisag unsa pa na yung number, bisag variable, bisag unsa pa na nga letter, basta i-raise na siya to powers of 0, ang equivalent ana na kaya 1. So simplify this expression 3x squared minus 1. So mo ni ang answer nimo sa derivative of x cubed minus x minus 3. So sa constant multiple rule, simple na sa gani siya. The derivative of a constant multiplied by a function f is the same as the constant multiplied by the derivative of the function f. So the derivative of k, which is a constant, multiplied by the function f of x is equals to k times the derivative of f of x. Mura ra nimo gipagawas ang constant sa outer equation para ma-simplify nimo, ma-derivative nimo easily ang f of x. So for instance, kay derivative of 3x4, ang atong k diri, ang ato ang constant 3k 3, then ang atong f of x kay x raised to the power of 4. So pag differentiate nimo ana, ipagawas na to ang 3, then i-differentiate na to ang x over 4 mo ni ang gibuhat dire. So dire proceed na ka sa power rule, 3 i-bring down 4 minus 1. So 3 times 4x raised to the power of 4 minus 1 is equals to 12x cubed. So kaning next example kay gigamit na to ang katong mga other nga constant nga naay Greek or symbol nga naka-indicate nila. So the derivative of pi x raised to the power of e. So we know na ang pi is constant, ato na siya ipagawas. Raised to the pi times the derivative of x raised to the power of e. So since ang x na to kay raise man siya to the power of constant, ma-apply dyan po na to ang power rule. So i-bring down na to ang e, then ang e atong i-minus 1. Since e dili man na to mahilabtan kay kuan man na siya, naman na siya value nga kanang never ending ang iyang decimal point, as is lang na nato. So ang ato ang i-simplify answer niya kay pi e raised to the power of pi e x raised to the power of e minus 1. And sa laws of exponent, if ang imuhang exponent kay naay kanang addition or subtraction nga operation, pwede na nimo siya ma-separate. If subtraction ang imuhang exponent, pwede na nimo siya ma-divide ang x. Simple, x raised to the power of e minus 1, same man siya base x. So ang kaning simplification na niya, x raised to the power of e minus 1 kay x raised to the power of e divided by x, pwede nimo siya ma-bring down ang x. So if addition ni siya, e plus 1, instead nga imong i-divide ang x, imo siya i-multiply. Mura na siya murag sabton. Mura na kanang sag-uho nimo sa laws of exponent. So the product rule mo na siya murag mas complicated. The derivative of a product of two functions is the derivative of the first function times the second function plus the derivative of the second function times the first function. So, mura na siya kanang puli-puli nimo i-differentiate ba, i-multiply nimo sa original, then i-plus nimo ang kato na sang imong gi-original, imo i-differentiate, imo sa i-times dire. So, for example, derivative of f of x times g of x is equals to the derivative of the first function f of x times the original function. Dili siya i-derivative, normal nga function na sa original function. Dire nga ikaduha nga term plus ang imong operation dire. Ang first term na sad, ang first function na sad nimo ang original, ang second function na sad nimo ang i-derivative. So for example, the derivative of quantity x plus 3 times the quantity x squared plus x. So ang imong f of x diri kay x plus 3, ang imong g of x kay x squared plus x. So sa description or sa description sa kana ato ang product rule, first ato i-differentiate ang f of x, ang first function, which is x plus 3 mao na derivative niya diri multiplied by original function g of x multiplied by the original function g of x mao nang gi-copy ra niya ang x squared plus x. Plus copy diri ang f of x kay murag mag-switch man sila position. Copy ra nimo ang f of x, ang imo na siyang i-differentiate ang ikaduha na sa function niya x squared plus x. So algebra ra ni siya nga ting imo na siyang i-simplify. So ang derivative sa x plus 3 kay 1 plus 0 times original function x squared plus x plus copy x plus 3 times derivative of x squared plus x, which is 2x plus 1. So FOIL method sa kaning part kani kay 1 ra man ni siya, so copy ra ni mo x squared plus x. Ang kani kay FOIL method, first term i-multiply mo ang first term x times 2x is equals to 2x squared. Outer term x times 1, which is x. Inner term 3 times 2x, which is 6x, and last terms 3 times 1, which is 3. Then combined like terms, natay x squared x squared plus 2x squared is 3x squared. Then natay x, napatay x, and napatay x. 6 plus 6x plus x is 8x. Then the constant 3. So mo na siya ang answer. Next kay quotient rule. Kani kay similar ni siya sa product rule but dala siya gi-add and gi-usab. The derivative of a quotient of two functions is the derivative of the numerator function times the denominator function minus the derivative of the denominator function times the numerator function, all divided by the squared of the denominator function. So sa kaning point kay nadyo man tay f of x, g of x, gi-divide lang siya. Ang first function nato kay f of x japon numerator, second function kay g of x. So ang equals ang derivative daw na niya kay imo i-differentiate first ang first function times the second function or nasa denominator, original dili differentiate pareha sa product rule, but in this case instead of plus na itong gamiton, minus itong gamiton, then switch na sabod silag sides, copy na sad ka the first function, then i-differentiate na sa mo ang second function na sa mo differentiate. Note nga ang kaning numerator sa kaning quotient rule kay dili jud siya mausab ha. Ang una jud ani kay differentiate mo ang numerator times copy the denominator minus copy the numerator times the derivative of denominator. Dili jud siya ma swap ang kaning f of x times derivative of g of x kay pag una dili siya kay minus man imong operation, mausab imong murag same logic sa kuan ba. Mayong kag 5 minus 1 is equals to 4. Pero mayong kag 1 minus 5 negative 4 ba imong answer, dili lahi iyang kuan. So dili ni siya pwede magka-swap. Di pareha sa kaning product rule nga pwede ni siya magka-swap kay addition man siya. Example like 5 minus 1 is equals to 6. 1 minus 5 kay 6 Japon. Bisag bali-balihon pa nimo, same ra Japon sila og kanang idea. Unlike sa kani kay addition man di siya magkabali-bali. And divided by tanan, i-divide mo siya sa squared sa imong g of x. So let's take example. The derivative of 5x squared divided by 4x plus 3. So ang imong numerator kay f5x squared, imong denominator 4x plus 3. So sa description kay first take the derivative of the numerator. So mo na iyang gi-differentiate times the denominator, wala gi-differentiate, minus copy the numerator times the derivative of your denominator. And divide all side. Tanan i-divide mo by 4x plus 3 squared. So lisod pa gini siya tan-aon but imo lang siya tagsa-tagsaon makuha jud nimo. So 5x squared derivative kay power rule, imo siya i-bring down ng 2, then ang 2 minusan mag 1 which is 1. That's why 5 times 2 times x. And copy the denominator nga function 4x plus 3. Then minus ang kaning mo gamit kay mo operate gani ka sa minus, imo jud siyang butangan og bracket. Dili jud na nimo hilabtan ang bracket unless ma-simplify nimo ang imuhang sud sa bracket. Kay minus sign maguna siya. If minus sign man good and then imong answer diri kay naay duha ka terms like x plus 3, x minus 3, x squared plus 3. Kay ang imong buhaton na imo mo guna i-distributive property ang kanay magong minus sign kay makapausab di siya sa imong equation. Unless sa positive, pwede ra gyud na way bracket imo ra siya isuwat tanan. So to make this clean, no, imo ni siya isud og bracket kay para imo ni siyang i-simplify before na nimo i-apply ang kaning minus sign. So kani kay copy 5x squared times derivative of 4x plus 3 which is 4. So that's why 5x squared plus 4 times 4 is equals to 20. Diha na nimo gitangtang nimo ang bracket which is mao ni dere. Imo siya i-simplify nga answer sa numerator 40x squared plus 30x. Imo siya kani kay gi-distributive property ra niya 5 times 2, 10 times x kay 10x. So imo siya i-distribute sa kaning 4x plus 3. So 10x times 4x is 40x squared and 10x times 3 kay 30x. So that's why 40x squared plus 30x minus 20x squared divided by the square sa 4x plus 3. Don't worry sa kani ganing denominator kay squared nga imo pa ni siya i-expand. Most professor kay dili naman na nila ipa-expand kay libog na kaayo ba. So as is ra nimo imong denominator unless ma-simplify nimo diha pa nimo i-expand or imo i-factoring. But in this case dili naman nimo ma-simplify as is na imong denominator. So next kay chain rule. The chain rule tells us how to find the derivative of a composite function. Now, composite function ay kanang a function that is inside a function. So mo ni yang differentiation, the derivative of f of g of x is equals to the derivative of the big function, let's call this big function f of g of x times the derivative of your small function g of x. So let's take for instance example, the derivative of x squared, quantity x squared plus 2 raised to the power of 3. Ang big function na to ani kay ang whole expression itself, the quantity x squared plus 2 raised to the power of 3 mo atong big function. Ang atong small function kay kaning raised of 3 mo ni ang x squared plus 2. So atong giingon kay derivative daw niya kay derivative nimo ang original ang big function, multiply nimo sa imong derivative sa small function. So atong gisunod derivative sa big function i-power rule na to, i-bring down ang exponent, then times sa inside nga expression copy lang x squared plus 2 and then ang exponent minus na to 1 multiplied by the derivative sa ato ang sud nga function or small function which is derivative of x squared kay 2x raised to the power of minus 1 and derivative of 2 is 0. So simplify ang kani nga part 2x and then kani pod i-simplify. So kana 3 times x squared plus 2 raised to the power of 2 times 2x kay kani times 2x times 3 6x times the quantity x squared plus 2 raised to the power of 2. I think that's all sa ako ang any question sa kung gi-discuss or paspas ra kayo. Hello. Lah, ni bag-o na abot. Sige lang, recorded man ni ang video, then i-post man sa ni sa kuan sa page. So you can watch lang. Ang kanilang jo importante kayo kay maom jud ni ang differentiation rules kay ma-apply jud ni siya sa tanan sa kaning mga ipang-discuss sa next nga mga tutors. Bale mao ni ang bread and butter sa calculus ba. So sa kaning subject man gud kay if you understand jud sa iyang main concept like dili lang kay sag-o lang sa mga formula. Bisa pagbali-balihon ka kay maka-answer ra jud gani. Kay nya saguha ka nang seryosoha jud ninyo kay mga ME ba mo tanan. Sa mga higher nga subjects like mga mechanics, mga physics nga higher, mga thermodynamics kay gamit jud ni siya. Kay dili ra man sa mga real world kay dili ra biya simple nga straight line ra tanan or ang rate of change na to kay straight ra. Changing ra ba to ang mga rates. So that's why calculus na rin sa tanan. Anyways, wala na question kay pasa na ko sa next tutor. I think wala na question no? So let's proceed lang sa next. Ako na yan share. Thank you.
Hello. Good afternoon, ma. Dungog ra.
Oh, dungog ra.
Thank you. Kana makita ra. Wait lang.
Yes, kita.
So, good afternoon, everyone. So, I am Kurtran Peralta and I am going to talk about higher order derivatives. So, the derivative of a function dy over dx is an expression that depends on x. Hence, f prime is itself a function of x and may be differentiated again to the nth time with respect to x. So basically, the concept of higher order derivatives is getting the derivative of the derivative. So such process different can be applied several times in succession, leading in particular to the second derivative f prime of the function f, which is just the derivative of the derivative. So it is expressed as d over dx multiplied by dy over dx equals to d squared y over dx squared, or f double prime or y prime. So para mas sayo ng pagsuwat sa kanang second derivative of the function, mas prefer na isuwat o kani siya f double prime or y double prime. So there are three types of function according to their higher derivatives. So first is terminating functions. So these functions are their nth derivative reduces to zero. So such functions have excuse guys. Saba kayong So I'm sorry guys. So first is the terminating functions. So their nth derivative reduces to zero. Such functions have positive integer exponents in their independent variable. So for example, a function is 3x to the power of 4 plus 5x plus 4. So in getting the derivative of this function, we will use as discussed by katong nag-una nako, the power rule. Distribute 4 to 3, 4 times 3 is equals to 12. Then minus 1, 12x cubed plus nam ni siya ikuan invisible nga kuan 1 dire, so 1 times 5, 5, then 1 minus 0. So as we all know that when a number or any variable raised to the power of 0 is equal to 1, so mawa na siyang x, so 5 na lang. And the derivative of a constant is 0, so makancel na siya. So the first derivative of this function is equal to 12x cubed plus 5. And so the second derivative is just getting the derivative of the first derivative. So this is the first derivative, 12x cubed plus 5. So again, use the power rule. 3 times 12 is equal to 36. Then subtract 1 from the exponent, which is equal to 2. So the second derivative is 36x squared. So we will get man ang kuan kung kanus amo 0 ang kuan. So we will get the third derivative again. So using still the power rule, which is distribute this exponent to the coefficient. So 2 times 36 is equals to 72. Then subtract 1. So 72x. So that's the third derivative of this function. And next is the fourth derivative of the function. So the fourth derivative is simply using again the power rule, which is equals to 72. And lastly, the fifth derivative of this function is the derivative of the constant, which is equals to 0. So that's why therefore this function 3x to the power of 4 plus 5x plus 4 terminates at fifth derivative. So let's have another example. We have the function 4x cubed plus 5x squared plus 2x plus 3. So getting the first derivative is again simply using the power rule. So 3 times 4, which is 12x, subtract 1 to the exponent, which is 2, 12x squared plus 10x plus 2. So that is the first derivative of this function. So Again, the second derivative is just the derivative of the first derivative. So we will get the derivative of this function. So again, using the power rule, 24x, and then this 10x, the derivative is 10. So we already have the second derivative of the function. And next, the third derivative of the function is 24. So since 24x man, so power rule Japan. And the fourth derivative is the derivative of this constant, which is equals to 0. So therefore, the function 4x cubed plus 5x squared plus 2x plus 3 terminates at fourth derivative. So again, terminates, which means kanang asa siya ni 0. So ni 0 ang kaning function siya at the fourth derivative. And next example is the function 5x squared plus 10x plus 10. So first derivative, simply using the power rule again, is equal to 10x plus 10. And the second derivative is 10. And the third derivative, which is the derivative of the constant, which is 0. So therefore, this function 5x squared plus 10x plus 10 terminates at the third derivative. So it is easy to determine no, nga kanang ang function ba kay kuan siya kanang terminating, since makita ra jud nimo like simple ra jud kay siya nga functions kanang mga positive integer makita ra jud nimo sa iyang structure ba, like mailhan na jud nimo nga kaning nga functions kay terminating ni siya, makita ra jud nimo sa iyang structure compared sa kanang mga rational functions like involving na mga kuan, mga square roots and kuan, mga exponential o mga logarithmic functions compared sa kaning terminating, which is una pa lang nimo tan-aw makabaw na ka nga mo zero ni siya. Whereas anis kani then kani siya and kani. So there's actually a way para makabaw ta when will the function terminate. So kanang dili na ta kinahanglan i-solve na to ang first derivative and second derivative. So we just have to let m is equal to the highest exponent in the function and let n be the number of times the function is differentiated to 0. So simply, the number of times the function is differentiated to 0 is just equal to the highest exponent in the function plus 1. So let's have an example. So we have this function 10x to the power of 5 plus 12x cubed plus 2x plus 5. So what is the highest exponent? So the highest exponent is simply this exponent, which is 5. So we have to let m is equal to 5. And we have the formula here is equal to n is equal to m plus 1. So n is just simply 5 plus 1. So this function, based on the formula given, we have 5 plus 1, which is equal to 6. So basically, the function ends at the 6th derivative. So the formula, base run as a formula. So we have to prove it para mas makabaw yung tayo sakto jud. So we have to differentiate this function. The first derivative of 10x to the power of 5 plus 12x cubed plus 2x plus 5 is by simply using the power rule. So kibaw na mo sa power rule kay gidiscuss na mo to ganina. So to review balik, so kaning exponent multiply sa coefficient, which is 10, then subtract 1 sa exponent. So 5 times 10 is equal to 50, then x, then subtract 1 is equal to 4, then same goes sa dire and dire. So dire 3 times 12, 36, then subtract 1, which is x squared, and 2, since naman siya 1 na exponent dire, then the derivative of constant is 0, so cancel na siya. So we have the first derivative. And then the second derivative again, simply power rule, we have 200x cubed plus 72x. And then to get the third derivative, we have to multiply again then makakuha ta og 600x squared plus 72. And then mo siya ang third derivative. So we have the fourth derivative. Fourth derivative is simply 2 times 600. So makuha na to 1200x. And then the fifth derivative is just simply 1200 since wala man siya exponent. Okay, 1 ra ba ang exponent niya dire. And the derivative of the constant is 0. So sakto siya guys. So ni 0 siya sa ika-6 derivative, which is sakto sa given nga formula, which is gingon na 6 derivative. So actually mas sayon ra if isuwat nimo ingani kanang close parenthesis niya 6 kaysa mag-ingani ka nga prime nimo y 5 ka prime. If daghan na kayo, mas sige ka daghan kayo diri nga 8 ka buok baron 8 mapuna ni siya tulo, which is samo kay siya messy kay tan-awon. Then mas nindot if ingani na lang siya enclose ang parenthesis then the number kung ikapila siya nga derivative. So therefore the function terminates at 6 derivative. We have another example. The function 10x to the power of 4 plus 2x cubed plus x plus 2. So what is the highest exponent in this function? So the highest exponent of this function is equal to 4. Then the formula given was to n is equal to m plus 1, which is the highest exponent plus 1. The highest exponent, which is 4 plus 1, so fifth derivative, so equals 5, which is the function. We all know na the function terminates at fifth derivative. So let's prove nga fifth derivative budget. So function is equal to y is equal to 10x to the fourth plus 2x cubed plus x plus 2. So the derivative of this is simply using the power rule again. We will have 4tx cubed plus 6x squared plus 1. So we have the first derivative. And then the second derivative, which is 120x squared plus 12x. And then the third derivative is 240x plus 12. And then the fourth derivative is 240. And then we have the derivative of the constant, which is 0. So the fifth derivative is 0. So which is same ra po diri sa kaning atong nakuha based given sa formula, which is the fifth derivative. So therefore this function 10x to the fourth plus 2x cubed plus x plus 2 terminates at fifth derivative. So another case which is ang function kay dili ingani ang kuan ang forma. The function is kuan kani ingani like x to the power of m plus ax m minus 1 kaning coefficient ning a, then gi-enclose siya into parenthesis, then raised to another kuan sa exponent. So the formula in getting the kung kano sa siya mo terminate is different sa katong kani, which is m plus 1 ra. Ang formula if ingani ang structure sa function kay we have to get the highest exponent, which is m, then multiplied by the exponent katong pilay kung pilay gi-raise niya sa kaning na-enclose sa parenthesis. Multiply then add 1. So let's have an example. Kaning kuan 2x to the fourth plus 4x cubed 4x squared plus 3x plus 2. So what is the highest exponent? So muna siya 4, then 3 plus 1. Muna siya ma-terminate siya sa 13th derivative. So masabtan naman siya diri kay nanay formula. So we have another types of function according to their higher derivative, which is non-terminating function. So compared sa katong unang type, which is terminating, kani siya kay kani nga functions kay can never be zero. Madili bisag unsa nimo bisag kapila siya i-derive bisag infinity pa kay di siya mo zero. So let's have an example. The cube root of x squared minus 2. So we can actually use power rule in this. Pwede na to siya makuan kaning x squared minus 2. Pwede na to siya ma-raise into 1 over 3. Then power rule distribute din na to. So na-discuss naman na siya ganina. So the first derivative is kani siya mo ni siyang results, ako na siyang solve 2x over 3 multiplied by x squared minus 2 raised to the power of 2/3. So that's the first derivative of this function. And the second derivative, which is kani. So sorry. And it goes on din siya guys hangtod sa kapila nimo siya i-derivative. Bisa kapila nimo siya i-differentiate guys, sorry. Makakuan siya di siya ma-zero, it can never be zero. And another example, which is y is equal to square root of x minus x squared. The derivative of this function is equal to 1 over, pareto ni siya guys, kani siya, pwede ra siya ma-power rule. So may man siyang x to the power of 1/2, then ang 1/2 kay ma-distribute nimo, so 1 over 2 nya mo ni siya 1 over 2 over square root of x minus 2x. That's the first derivative. Then the second derivative, mo ni siya maning result sa second derivative. So and it goes on Japan siya, same ani. So compared sa katong unang type, which is kuan kanang katong terminating functions, na makita ra nimo ang sa base ang structure na terminating siya. Ang non-terminating functions ang non-terminating function sad kay kuan kanang dili siya mo end. So makita nimo siya mostly ang mga non-terminating functions kay kanang mga kuan, mga rationalized ba ay mga rational function, mga ngana. Last type of function according to their higher derivatives is the recurring functions. So this happens in transcendental functions. The derivatives are kanang magbalik-balik ra ang derivatives niya guys kanang. So what are these transcendental functions kanang? Mo ni siya mga functions kanang mga non-algebraic functions ba? Like example kanang mga inverse function, mga logarithmic, mga hyperbolic, o kuan mga unsa pa man hyperbolic. So, basta mga kana siya nga mga functions guys matakol na ninyo mga nga functions, calculus ninyo like sa kanang mga kuan sa integral, mga inverse. So for example, y is equal to sine x. So namin tayo rule nga derivative sa sine kay cosine sa mga trigonometric functions ba. Mga naramay ka ng mga differentiation rules sa trigonometric function. So the derivative of sine is equal to cosine sine x, diba? Mga cosine x ra. Then the derivative of cosine is equal to negative sine. So the first derivative of sine x is equal to cosine x. And then the second derivative is negative sine x. And pwede na siya igawas na itong negative. So the derivative of sine x, okay, para sa ni cosine. Cosine ba ito? So cosine then negative man to, so negative cosine x. Then igawas na sa din na ito balik ang negative. Sorry. The derivative of cosine, which is negative sine x, then negative naman to gawas, so ma-positive siya. So muna siya sine x. Then the derivative of sine x is equal to cosine x. So as you can see, nagbalik-balik ra siya. Na kani siya, the first derivative is cosine x, then the fifth derivative of the function sine x is equal to cosine x sa Japan. So one example of this function guys nga magbalik-balik ra. So mga to siya. So I have here five problems on higher derivatives. So first is solve the first and third derivative of the function x to the fourth minus 2x cubed plus 10x plus 5. So you have to rewrite the function x to the fourth minus 2x cubed plus 10x plus 5. So makuha na siya, makita naman nato nga kuha siya, terminating function siya kay structure pa niya makita na nato. So atamang ang gipangayo kay ang first derivative. So the first derivative is using the katong ganina power rule Japan. 4 times the constant nga 1 which is 4, then subtract 1 to the exponent which is mahimo siyang x cubed, then kani siya distribute ang 3, so mahimo siyang 6, then ang 3 minus ang 2, so 6x squared. So ang 10x derivative sa 10x kay 10, then the derivative of a constant is 0. So cancel na siya. So nakuha na nato ang first derivative. So we have the second derivative. Para makuha na tong third derivative, we'll have to get the second derivative first. So the derivative of this function, so 3 times 4, 12, then x squared minus 1, then same goes which is makuha na to 12x. Then we have to solve the third derivative kay mamaya gipangayo. So the derivative of 12x squared minus 12x is just simply 24x minus 12. So we already have the unsay gipangita, which is first and third. So this one and this one. Next is much complicated gamay. Okay, we have the trigo functions. We're using trigo function. So solve the second derivative of sine 2x squared minus 3x. Kani siya, ma-apply siya ang chain rule katong gitudlo ganina guys. So we have to get the i-rewrite sa nato sine 2x squared minus 3x. So in using chain rule, kuhaan sa natong derivative sa kaning 2x squared minus 3x, which is 4x minus 3. Is 4x minus 3. Then the derivative of the whole kani siya. So what is the derivative of sine presto ganina, which is cosine? Then copy, we have 4x minus 3. Then cosine 2x squared minus 3x. So we have to get the second derivative man. So in getting the derivative again, so ang pagkuha sa derivative if multiplied kay katong gi-discuss ganina kay derivative ani una 4x minus 3. So 4, then copy this cosine 2x squared minus 3x, then minus kanina pod ang i-derive, which is 4x minus 3, then copy sad ni 4x minus 3 squared, then ang derivative sa cosine, which is sine, muna siya sine 2x squared minus 3x. So that's the second derivative. Muna na-solve na to ang second derivative of the function. So next, find the point on the curve y is equal to 2x squared. So murag word problem na ni siya kang application gamay. So find the point on the curve y is equal to 2x squared plus 4x for which y prime is equal to y double prime. So ang find the point on the curve daw. So what is y prime? We have the function. So what is the first derivative of this function? We have 4x plus 4. So kuha na tong y prime. And then the y prime is equal to y double prime and daw. So we have to get the second derivative, which is the derivative of this 4x plus 4. So basically, the derivative of 4x plus 4 is just 4. So ang gingon kay equal man daw sila. So 4x plus 4. So find the point on the curve. So we have to sayop day ko. Anong giko nako? 4x 0. 0 din siya guys. Sorry na sayop na ako guhan. So pag-edit. So we have ma 0 ni siya day. Ay sayop din ako kuhan. So dapat day guys minus din ni siya minus. Sayop din ako kuhan. Minus 4x niya. Ito ako yung edit. Minus 4x, then minus 4x. 4. X minus 4. Mana siya, 4x is equal to 8. And then, over 4 ang whole equation, which is x is equal to 2. Then we have down the value of x. So in order to find the value of y, we just have to substitute the value of x is equal to 2 sa sorry guys, nasayo. Kuhaan, so nakuha na tong value sa x, no? We have to, in order to get the value of y, kay substitute na tong value of x dire sa function. So 2 times 2 squared minus 4 times 2, which is 2 times 2 times 2 is equal to 8, minus 8 is equal to 0. So the point on the curve is at point, we have the value 2 and 0 at point 2, 0. So again, we have another problem. Given that the function 2t cubed minus 10t squared plus 15t over the time interval 0, 5, find the velocity and the acceleration functions as functions of time. So we all know that the velocity, guys, is the instantaneous rate of change man, and the derivative mo sa ng rate of change mo sa siya ang rate of change in terms of the independent variable. So simply in getting the velocity, sayon ra kayo i-derivative, ikuha na natong derivative sa given function kay rate of change naman sa ng velocity. So mo na siya murag application sa kuan, murag ang application sa higher order derivative sa in real life kay murag sa cars kanang mga pagkuha sa velocity. So kani the function t 2t cubed minus 10t squared plus 15t plus 5. So we just have to differentiate the 3 times 2, which is 6t squared minus 20t plus 15. So we have the velocity. This is the velocity. And we also have to find the acceleration. So ang acceleration kay mamsa na siyang rate of change sa velocity. Mora Japon. So ang acceleration there is equal to just the derivative of the velocity. So we have mo ni siyang velocity man, di ba? So ang acceleration makuha na nato siya given the given nga ang acceleration is just the rate of change sa velocity. So 60 squared minus 20t plus 15. Mo na siyang velocity, then the derivative of this is simply 2 times 6, which is 12t, then minus 20. Makuha na siya ang velocity o acceleration using this the derivatives. And lastly, the third derivative of cosine 7x plus 2. So rewrite the function. Cosine squared na. So cosine 7x plus 2. Then the derivative of cosine ay using the chain rule again. Katong itulo ganina sa katong mas naguna nako. The derivative of this 7, which is 7, igawas na siya. Then the derivative dayon ani, which is negative sign. Ang derivative ng cosine kay negative sign. So negative 7 sine 7x plus 2. So that's the first derivative. And again, atong gipangita ang kanang third derivative man, so we have to differentiate again. So katong gi-mention ganina, if nagay constant pwede naman siya igawas katong differentiation rules nga gi-discuss sa katong first presenter kay pwede ra igawas daw ang constant. So kani akong pwede na igawas ang negative 7. Then again using chain rule na pod, which is kaning 7x plus kaning 7x plus 2, which is 7. Then the derivative of sine, which is cosine. Mao na siya, makuha na to is negative 7 times 7, which is negative 49 cosine of 7x plus 2. Yeah, third derivative man itong gipangita, so we have to differentiate again. So pwede na natin ipagawas ang negative 49. Then igawas na itong constant na negative 49. Then using chain rule, differentiate niya sa sulod, which is 7 na mo siya 7, and then the derivative of this. So the derivative of cosine using the differentiation rules sa trigonometric functions kay negative sign. So man na siya negative sign, then negative 49 times 7, which is 343, then the sine of 7x plus 2. Then positive siya kay negative sign, then negative 49 times 7. Mana mas positive. So the third derivative of the function cosine 7x plus 2 is equal to 343 sine 7x plus 2. So, mga to siya. If na may questions kay raise hands lang din or comment. Thank you. Kaya na pa yung mga percent na.
Sumobra ba? Guys, makadamot naman ako. Oh. So guys. Hello? Dungog ra ko? Okay. Mag-share screens ako ah. So, this topic is just an application for all the topics that the previous tutors have discussed. So, what is implicit differentiation? So, it is the process of finding the derivative of a dependent variable in an implicit function by differentiating each term separately, by expressing the derivative of the dependent variable as a symbol, and by solving the resulting expression for the symbol. Also, it allows you to find the derivative of y with respect to x without having to solve the given equation for y. The chain rule must be used whenever the function y is being differentiated because our assumption that y may be expressed as a function of x. So what is implicit function? It is a function which is not simplified form of its dependent variable in terms of its independent variable. Also, in many cases, these functions cannot be easily transformed into explicit ones or even impossible to do so. That's why there is a specific process to solve their derivatives other than converting it into explicit functions. And to solve dy over dx or simply y prime, using the previous processes is required. So, using implicit differentiation to find dy over dx or y prime, there are 4 steps to success. First, differentiate both sides of the equation with respect to x. Second, get all terms containing dy over dx alone on one side of the equation. And third, factor out dy over dx or y prime. And lastly, solve for dy over dx by dividing both of the sides by the expression remaining in the parentheses. Example number 1. So the given is y cubed minus 5x squared equals 7y squared. So the first thing you must notice or kanang test is if naabay mga rules nga makita, like pwede ba maka-apply of product rules or any differentiation rules. So for this one, basic raman ang given. So y cubed minus 5x squared equals 7y squared. So proceed on differentiating. So 3y squared y prime minus 10x equals 14y y prime. So mo na yung step 1. For step 2, it is said nga i-combine mo ang mga expression nga naay dy over dx or y prime. That's why the 14y y prime is transferred to the left and the 10x is transferred to the right. So, making 3y squared y prime minus 14y y prime equals 10x. Then, factor out y prime. So, y prime times the parentheses of 3y squared minus 14y equals 10x. And to solve for y, divide the expression of, by the inside parentheses. So 10x over 3y squared minus 14y. So example number 2. So tanaw na to ang expression. Nakakita ta nga nay xy squared, which is a product of two expression wherein u is equal to x and v is equal to y squared. So ari na nato i-apply ang product rule nga d over dx uv is equal to u dv over dx c du over x dx. So 5x squared differentiate. So 10x plus ang gamiton ang product rule u dv. So ang u is x times the derivative of v, which is y squared ang v. So ang derivative is 2y y prime plus v, which is y squared times the derivative of x or derivative of u, which is x, is 1. So plus 2y squared and derivative 4y y prime is equal to 0. So combine 10x plus 2xy y prime plus y squared plus 4y y prime is equal to 0. So
i-groups nimo kung asa ang naay y prime. So ibutang sa left o ang wala sa right. So 2xy y prime plus 4y y prime is equal to negative 10x minus y squared. Factor out y prime. So y prime times 2xy plus 4y is equal to negative 10x minus y squared. Therefore, y prime is equal to negative 10x minus y squared over 2xy plus 4y. In this case, pwede nimo i-factor out ang negative 1 if ganahan ka, or pwede ra sa nimo nga as is lang. Pero dapat note, final answer should be in the simplest form. Example number 3. So, tan-aw nimo. So, Andre, duha ka buok rule ang pwede ma-apply. Ang rule nga naay radicand sign o ang product rule. For this one, the radicand sign, pwede mo gamit aning power rule, which is the power is 1/2, or pwede sa ang kani. So, square root of x plus y plus xy is equal to 27. So, d over dx square root of u is equal to du over dx square root of 2 square root of u. O sa xy, wait sa, teka nag-chat doon. Wait a minute. Wala na dahil. Habis na kung di ko ba doon mag... So, tabi back ka na. So, d over dx square root of u equals du over dx all over 2 square root of u. Muna siya pwede ma-apply aning radicand. So, for the xy, so product rule, d over dx of u times uv equals u dv over dx plus v du over dx. So, ang u na to, du over dx man daw. So, ang derivative of u, which is x plus y. So, derivative of x equals 1. Ang derivative of y is y prime. All over 2 times square root of u, which is x plus y. Plus, for the product rule, u is x and v is y. And the derivative of v is y prime. Plus, v, which is y, and the derivative of u, which is x and which is 1, is equal to 0. So, 1 plus y prime all over 2 square root of x plus y plus x y prime plus y is equal to 0. Atong i-distribute ang denominator para whole rank expression. So 1 plus y prime plus 2x y prime square root of x plus y plus 2y square root of x plus y equals 0. Group ang expression nga naay y prime. So y prime plus 2x y prime times square root of x plus y is equal to negative 2y square root of x plus y minus 1. Y prime, so parenthesis, 1 plus 2x square root of x plus y is equal to negative 2y square root x plus y minus 1. So, i-divide both sides by 1 plus 2x square root of x plus y. Y prime is equal to negative 2y square root of x plus y minus 1 all over 1 plus 2x square root of x plus y. So, na ko'y exercise number 1. If ganahan mo, please lang answer niya. I-reply lang sa comment section kung unsa inyong ma-arrive nga answer. So, exercise number 1. Solve for the value of y prime in the given equation. Tagalog, like 5 minutes lang to answer. Yeah. I-check if the same ba. Alam mo kauwaw mo senda. So time check 4:47. So by 4:52 pwede na ako ikaw ng answer. Game ra ba mo answer? Wala may response. So, ako na lang i-ikon ang answer. So, for this exercise, so, solution. 4x cubed plus 7y cubed minus xy equals 16. So, differentiate. 12x squared plus 3 times 7, which is 21, y squared y prime minus xy prime plus y is equal to 0. So, 12x squared plus 21y squared y prime minus xy prime minus y is equal to 0. So, i-distribute ang negative sa duha ka expression. So, 21y squared y prime minus xy prime is equal to transfer y minus transpose again. So, negative 12x squared. So, factor out y prime. So, 21y squared minus x is equal to y minus 12x squared, resulting to y prime is equal to y minus 12x squared all over 21y squared minus x. So, maura na ang implicit differentiation. So, kani nga lesson is more of an application lang. As long as makasabot ka sa rules o gunsaon ang way sa pag-differentiate sa equation, wala ra jud ni problema nga lesson. So, that's all. Wala na ba'y question sa uban? Kung wala na questions, if okay lang, pwede ka nang open cam lang ta, like, para documentation lang. Okay rin mag-open cam ta, guys? How about ang uban? Okay rin mo sa mga tutors? Murag wala may balak. So, to Earl James Cabanyog, thank you for participating and joining us for this session. We appreciate it and hope nga nakatunan sa ato ang session.